Hey, welcome. My name is Matt Allen with SIMCON Solutions, and today I'm going to be walking you through a simple demo warehouse simulation model to give you a little bit of an idea of how simulation can help inform your warehouse design and management decisions. So before we get directly into the model, I would just like to briefly review some of the more common warehouse design challenges. So first and foremost, you need to define your racking systems. So you need to know how much racking capacity that you need overall and for each SKU. You also need to determine what kind of slotting strategy that you're going to use. A lot of warehouses these days tend to reserve their most accessible racking locations for their fastest moving SKUs. But simulation enables you to evaluate any number of slotting strategies that you could imagine. Immensely helpful for determining which slotting strategy will work best for your particular system. Thirdly, if you happen to be a warehouse that intends to employ pick-drop locations, where, as you can see in the picture on the bottom right there, you basically stage pallets at the end of each aisle. One of the things you may need to figure out is how many pick-drop locations do you actually need, and how do you prioritize their allocation. And lastly, you need to determine your inventory management strategy. So how often do you need to reorder material for each SKU, and how much do you need to order each time? All right, last slide. So once you've got your pallet racking systems defined, you know how much capacity you need, you know how you're going to distribute pallets throughout your warehouse. Next thing you need to do is define your material handling systems. This typically includes a vehicle system of some kind, either manually operated forklifts, or if you're one of the warehouses moving more toward automation, maybe an AGV fleet or two, and then conveyor systems potentially as well. So for the vehicle systems, the most important thing you need to figure out is how many actual AGVs do you need. You want to be able to keep up with demand, but you also don't want to waste money on a bunch of extra AGVs that you don't need. So that's something that simulation can really help out with a lot. Some other things that also factor into the determination of fleet sizes include mission priorities. How do AGVs determine which mission to perform next if there are multiple candidates, and also the traffic control. So the path network, travel directions, routing algorithms, these are all things that are going to have a significant impact on the number of AGVs that you actually need. Finally, conveyor systems. So these aren't included in every warehouse, but they are included in some, so we're including it in this slide. If you have your AGVs delivering pallets directly to a conveyor, and then the conveyor handles the final delivery, the delivery of the pallet to the final destination, conveyor system design can come into play. And in those cases, you may have multiple conveyors feeding into one central sorter conveyor, which is responsible for distributing the pallets to their final destinations at a higher rate of speed. In that case, slugging logic and merge logic can come into play. Configure simulation. So let's check out our input dashboard for the simulation model. So as you can see here, we have a whole bunch of options and parameters that define how the simulation or how the warehouse is going to operate during the simulation run. So we have warehouse parameters, we have parameters that define the VNA and CB12 AGV fleets, and then we have parameters that define the conveyor logic. And so just keep in mind this is a simple demo model. So this is just a subset, an example of some of the options and parameters that we can pull out of the model and make available to the user to experiment with. So I would also mention that for this simple demo, we just have this input dashboard, and we have several output dashboards that we're going to review to look at the simulation results and system KPIs. But in reality, when we develop a model for a client, we will also typically include an input spreadsheet which drives the simulation model, where we will pull out as many model parameters as we possibly can to ensure that the model is as data-driven as possible. Similarly, on the back end, each simulation run automatically generates a complete collection of simulation results in the form of output data files. And these data files can be in any format that you prefer. They can also be accompanied with an Excel spreadsheet, which has a macro baked into it, so that you can automatically import all of your output data files into a cleanly formatted spreadsheet for review. And this enables you to perform additional analyses to glean additional insights into your system. So I'm just going to run this once with these default parameter values, and then we're going to look at the output, and then we're going to run it one more time. And I'm going to show you how some of these options and parameters can affect system performance. Okay, so as you can see here, we have a 3D representation of the warehouse in the model. So you have your AGVs moving around. Your yellow AGVs are your CB12s, so those are responsible for moving pallets between the pick drop locations and the conveyors. And then you have your off-white colored AGVs, which are your very narrow aisle AGVs. So you'll see them predominantly staying within the aisles, although they do have the flexibility and freedom to transition between aisles. You'll also notice there's a layout underneath the warehouse racks. This is something that we do whenever we build a simulation model for a client. We'll typically import a CAD drawing of the facility into the simulation software, and then we'll build the model on top of it. This helps ensure that the model is built to scale and serves as a valid representation of the system under study. But for the purposes of this demonstration, it's a little bit noisy, so we added this toggle floor button to just go ahead and hide that. You'll see these yellow lines illustrate, where the AGVs can move. That's the basic path network. So the basic flow in the system, pallets from receiving arrive at these transfer conveyors up the top of the facility. So from the north side of the facility, they're checked into the WES system, and then these yellow CB12 AGVs transfer them from those conveyors to the pick drop locations, and then the V&A picks them up from there and stores them in the pallet racks. When some other area in the facility needs a pallet of raw material, a V&A AGV goes and finds a pallet of that material within the racking, pulls it down, drops it at a pick drop location associated with that aisle, and then a CB12 comes and gets it and delivers it to the outfeed conveyors located at the bottom of the facility. So here you can see some of the conveyor merge logic at the south side of the plant. So you see we have 2 merge conveyors, and you can see the pallets are accumulating. You can also see that we're releasing a maximum of 3 pallets at a time, if you can recall from the input deck. You can also see we have kind of a cascading release structure where pallets wait for upstream pallets to clear and then piggyback behind them. So this is just a basic example of the type of custom conveyor and merge logic that you can code up and evaluate using simulation. So you may notice that the pallets are color-coded by SKU. You may also notice that the yellow pallets are co-located in the middle of the warehouse, and that's because those pallets require a different size racking location. So that's just an example of some of the custom logic that you can code up in a simulation model and actually visualize how your system will play out in reality. Now for this demo model, we have 4 dashboards accessible via the buttons and the ribbon across the top of the screen here. Of course, keep in mind that this is just a demo, and our actual simulation models will be accompanied by a complete set of output data files. So first, we're tracking live warehouse statistics and warehouse KPIs over time. So these plots and statistics are updating constantly in real time as the model runs. So we're tracking how many pallets are in the warehouse, how many pick drop locations are allocated and occupied at any given time, doing the same thing for the racking locations, and we're also tracking time and system for each pallet. Alright, next I'm going to go to the material statistics. This dashboard provides a little bit more of a granular view of what's going on, so you can actually see the current raw material inventories at any given point in time. So you can see cups and cases are by far our fastest movers. We have significantly more pallets of those SKUs. And then you can track the time and system for each raw material type. You can also look at these statistics by aisle. So yeah, here you go. So this is for aisle 1. So aisle 1 only has racking, racking on one side of the aisle. So you'll see it's only got 250 locations. If I click this drop down and I go to aisle 5, and that's in the middle of the warehouse, so you actually have 500 locations there. And then for each aisle, you can see how many pallets of each SKU are available in that aisle current at any given time, and you can see on average, how many of their pick drop locations and racking locations are allocated or occupied. So that just gives you a little bit of an idea of some of the metrics that you can track and report. So here we have a AGV statistics dashboard. So here we're tracking and reporting KPIs for each AGV fleet independently. So here you can see the V&As are only utilized 67.8% of the time on average. So that utilization is a little low. As industrial engineers, we usually like to try to get the utilization up to 80 to 85%, somewhere in that range. Another thing to consider here is the wait times. So you can see the average store in and store out wait times for the V&As is about 15 seconds in both cases. So it's pretty consistent. And that's a product of our mission priorities being FIFO for both AGV fleets here. Similarly, for the CB12s, only about 70% utilized on average. Store in and store out wait times are about the same, 0.01. So again, that's a product of the FIFO mission priority scheme. So that's just a brief example. So that's with the default parameter value. So let's say we want to use this information and see if we can't improve our system performance or maybe save some money by getting rid of some of these AGVs we thought we needed. So I'm going to go back and reconfigure the simulation here. So I'm going to drop the number of VNAs to 6. I'm going to drop the number of CB12 AGVs. Let's go ahead and try to drop that to 12, see how that plays out. And let's prioritize store out in both cases so we make sure we never run out of material at our downstream production lines. And then let's try to prioritize the allocation of pick drop locations in the center aisle for both storage and retrieval. So alright, I'm just going to fire this off, see how this plays out here. Okay, so since most of the changes we made were specific to AGVs, let's jump straight to the AGV statistics dashboard and let's fast forward the simulation and see how this pans out. Okay, so almost immediately you can see that removing one of the VNAs increased the utilization of the VNA fleet size. So it jumped up from 69, 70% to almost 80%. You'll also notice that the average wait times did not increase significantly. If you recall, before it was about 0.25 minutes or 15 seconds for both store in and store out missions. Now, you're looking at 0.2 and 0.35, so that's not a significant increase. So that indicates that you can get rid of this VNA AGV. That will not significantly hurt your system performance. Also, you'll notice that the average store out wait time is only 0.2 minutes, whereas it's 0.35 for store in missions. And that's indicative of changing the mission priorities so that the AGVs always prioritize store out missions. Okay, so moving on to the CB12 AGVs, you'll notice the utilization actually didn't change all that much. It's still hovering right around 68%, even though we got rid of 2 AGVs. So that's actually a function of the new prioritization scheme we enforced, where we're prioritizing the allocation of pick drops located in the center aisle. Since those are significantly more accessible to the CB12s, they have less distance to travel on average per mission. So you don't need as many of them. So that just goes to show how important the decision logic is in terms of determining your fleet size requirements. And that's something that's virtually impossible to capture in a static spreadsheet model. So as a matter of fact, let's see if we can improve that just a little bit more. So I'm going to go back to the home menu. Okay, so I shaved another 2 CB12s off this time. So now we're writing out with 6 and 10. So let's see how that plays out for us. Once again, I'm just going to jump straight to the AGV statistics dashboard here. Okay, I'm just going to fast forward. Okay, so yeah, now the CB12 utilization is up to about 81%. So that's about what you would expect to see. It looks like 10 AGVs should be sufficient. You'll also notice the average store in and store out wait times didn't significantly increase either. So 10 AGVs should be sufficient for this facility. Okay, so that's all I have for this particular demo. I hope you enjoyed it, and I hope you learned something and feel like you know a little bit more about how simulation can help you out in your warehouse design endeavors. If you would like to reach out to us or have any questions about the simulation model or warehouse design in general, feel free to reach out to either Jeremy or myself using the contact information listed on the screen. Thank you for listening.